Okay, it's just a very simple and hopefully very quick video as well. Just some reflections that I would like to share regarding to the potential use of techniques such as Monte Carlo for within our fire engineering context. So based on some of my experience previously, using that technique or model sampling, I just would like to share my thoughts. Monte Carlo is a model for sampling, for getting points, for selecting, let's say, scenarios where you want to make decisions where you don't know very well about your system, for example, in summary. And the technique has been largely used globally, very popular, and I think also because of the name as well, which comes from the casino, and then it tells already the stochastic nature as well, is also reasonably simple, and there are quite few software which are based on this algorithm technique. The software or the model itself has been used largely as well in the finance industry, where the factors or the variables, they are very speculative, and their nature tend to be qualitative or semi-qualitative. In our context, engineering, for example, specific fire engineering, let's say when we are trying to define the fire resistance of a structure or the elements, the indexes or the factors or variables, they are quantitative by nature. So an example, like in physics, we talk about gravity, we talk about mass, for example, density, energy, enthalpy, pressure. So they are quantifiable and they are deterministic by nature in that sense, okay? So we can see there are two different contexts, there are two different areas, okay? From that analysis, we can start to think maybe perhaps we should be reflecting further if we should be using this technique to our fire engineering problems. Okay, but let's think about this simple graph here, which is extracted from one paper which I have published, and actually from one of the chapters of my thesis, my PhD thesis, I dedicate on statistics and on DOE techniques, design of experiments, and I mentioned about Monte Carlo as well. So let's say that we have a problem where we have a function y, right? We call response, and then we don't understand how two factors, two variables, they interconnect, how they work amongst themselves or between themselves, and how this relation between them will actually impact the value of the function or the response, okay? So we have no clue. And that's when Monte Carlo can be used. So we then define, okay, the nature of our design variables. That's called design variable 1, design variable 2, okay? And we know the lower values and the upper values for each variable. And with that, we then create a design space. So in a 2-dimension, 2D. So that space will actually contain all the possible combinations between all the values from each variable domains. That's the coordinates from the Cartesian plan. Fine. Okay, so we can see that ideally, right, if we want to get a realistic response or realistic sampling, we should have all the possible points that we have in the design space. Clearly, I wouldn't say it's impossible, but it's unfeasible. It's not practical, yeah? Because can you imagine, an experiment can be a computational simulation. It can be a real scale test or a lab test, okay? So it can take time, it can be costly, and etc. So Monte Carlo then can provide us reduced numbers and some way of trying to find the points there. So as the algorithm it's randomic, it's probabilistic. So in the first sampling that we do, we might get points, ideally and hopefully covering mostly the design space, or maybe not. We might get points in the middle of the design space. We might get points around here. We might get points in the corner, as I have highlighted here in this gray area. So my point is that Monte Carlo will not give the certainty that we are actually picking up strategic points in the design space. The strategic points would be getting the points in the corner, which represent all the combinations between the upper and lower values for each variable, yeah? And ideally in the middle as well. It's kind of similar when we are working with geotechnics and for really understanding how the mechanics of the soil work, we should be taking samples in very strategic points of the soil within the land, and for understanding the geomorphology of the soil. It's an analogy anyway. But Monte Carlo doesn't really give this certainty, and that's why it's recommended that we should be doing more sampling, a certain number of sampling, 50, 100, 600, 1000, you name it. But even though we still don't have the certainty that we will have a proper representative design space, maybe yes, maybe not, because the nature of these techniques is completely probabilistic. So my point is, given the nature of Monte Carlo, we should be challenging, we should be really thinking twice, 3 times before considering using that model or this technique for making our decisions in fine engineering, okay? So my recommendation as a fine engineer with a little bit of knowledge on that area is that problems that involve assessing the possibility of reducing the structural fire resistance, or the possibility of assessing, let's see, the combustible materials of one area of the building, they should not be assessed using stochastic models. We should be deterministic. We should be prescriptive, because these elements in the fire safety of the building, they are crucial, especially for the structure of the building. So I think we should be really be cynical and quite and thoughtful about that. The paper, it's available actually for whoever wants to read. It's here in this, in this link there. Okay, that's uncertainties in evacuation modeling. So I talk about evacuation modeling now. I publish with another colleague as well, but the concept is for every model actually. And we discuss about DOE techniques, design of experiments, where there are many techniques. as alternative solutions or alternative approaches to Monte Carlo in the fine engineering. In another problem or similar kind of a context, I also would recommend when you think of using multi-criteria decision-making models or techniques, such as the AHP, the analytical hierarchy process, which I have published paper and also on my dissertation as well. And actually on the CIBSE Guide E, chapter 5, which I wrote, which I co-authored part of that, I mentioned that it's possible to use some of these models, but with some prudence. And by the way, the chapter 5 is the same chapter 5 of the edition of 2019. It's the same. It's another conversation as well. Anyway, so these models, they can be useful, but again, we should be careful when and how to use them. So again, for cladding assessment or structural fire resistance, for me, it's a non-goal. And I can give an example. A few years ago, I declined a job because the insurance company on that time were requesting, but almost demanding that we should be using one of these multi-criteria decision-making models for assessing the cladding, for selecting the type of cladding. And that was before Grenfell. And because I know about these models, a little bit about them, as I call the black box, what is behind them, it's a no-go, because it's again, it's very randomic, it's very stochastic. And for some elements, the fire safety, and we should be deterministic, we should be very, in my view, very prescriptive, almost wouldn't say over the top, but actually even increase the safety margin. And when we are using stochastic models for making decisions on life safety, I think it's a very unwise decision to make, and it's completely unscientific, in my view. Anyway, so if anyone wants to get in touch, exchange ideas, I'm always available to discuss about that, but that's science applied to the real problems. And I think these models, they are useful to certain problems, but some others, we should be very careful and almost cynical using the French Enlightenment kind of approach anyway. Yeah, so there was just a quick reflection on its applications. Good stuff.